Day 280 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 172, factorial trailing zeros. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now, let's see what the question says. Question says, given an integer n, return the number of trailing zeros and n exclamation point. Note that n exclamation point equals n times n minus 1 times n minus 2 all the way up to times n minus 3 times n minus 2 times n minus 1. So now that we kind of understand what the question is, let's get into the examples. But before we get into the examples, let me show you exactly what they mean by this n exclamation point, right? So with this n exclamation point, all it's doing is it's taking n and it's multiplying every number in between 0 and n all the way down to 0. For example, say we want to do, let's look at example 1, right? So in example 1, we have n equals 3, the output is 0, explanation says 3 exclamation point equals 6, no trailing zeros. So let me show you what this 3 exclamation point means. So we had 3 exclamation point, that equals 3 times 2 times 1, right? And that is going to equal 6. Boom, that's what it says. So that's how it is. Another example, right, would be, so, and as you can see, 6 has no trailing zeros, right? So that's why the output is 0, because there's no trailing zeros in 6. So let's look at example 2 where it has an example of where there is a trailing 0, right? So in this example, in example 2, we have n equals 5. This time the output is 1. It says 5 exclamation point equals 120, which has 1 trailing 0. So let's go through it just so I can show y'all what that means again. So 5 exclamation point equals 5 times 4 times 3 times 2 times 1. That's all it's doing. That's all that 5 exclamation point equals. And that is going to equal 120. So as you can see, 120 has a trailing 0 right here, only one trailing 0, so the output is 1. Now remember, we are returning how many trailing zeros there are. We're not just returning the output of what this 5 exclamation point equals. We want to know how many trailing zeros are at the end, or at the final product or the final solution of 5 exclamation point, which is 120, and 120 has 1 trailing 0. So once again, we don't want the final answer of 5 exclamation points. We want how many trailing zeros does the final answer actually have. So let's look at example 3. Example 3 is pretty simple. We have the input n equals 0, and of course it's just going to be 0 because there's no multiplication going on. But I guess that could be a trick question, so you know that the 0 itself does not count as its own trailing 0, right? The output would be 0 if n equals 0. So now that we understand what the question is asking and we understand what the n exclamation point means, let's get into the fun part, the actual solution, y'all. Solution is not that difficult. We're in the math part of the LeetCode Top 150 interview questions, so I mean, I hope you like math because that's what we're going to be working on, and that's why this is it's a lot of math going on with this solution. Or not really the solution, just the question in general. But now, let's see how we're going to do this, right? First thing we need to understand is that the number of trailing zeros in n exclamation point is determined by the number of times 10 appears as a factor in the numbers from 1 to n, right? So if it has a 0 as an n, if it has a trailing 0, that means it's a factor of 10, or 10, yeah, so that means 10 can go into it however many times up to n, right? And since 10 equals 2 times 5, and there are way more factors of 2 than there are factors of 5, then the count of trailing zeros is going to be determined solely by the number of times 5 appears as a factor, right? So first thing we need to do is what we're going to do, first thing we're going to do, we're going to say, come in this function, we're going to say return stride. Then we're going to open up the parentheses. We're going to say from colon 0, comma 2, colon n plus 1, comma by 5. So that's where that 5 comes from, because there will be way less factors of 5 than there will be of 2. But we're trying to get to the factors of 10, and 2 times 5 is 10. So we're just going to look for the factors of 5, right? Then we're going to come over here. We're going to say dot reduce, open up the parentheses, into 0. Then we're going to open up the brackets, right? Now we need to get the current multiple of 5. So in order to do that, we're just going to say value equals $1, just like that. Now we need to check how many times the current value contains the factor of 5. If a number is a multiple of 5, it contributes at least one factor of 5. If a number is a multiple of 25, it contributes an extra factor of 5. And if a number is a multiple of 125, then it contributes an extra factor of 5, right? So let me give you an example, like 5, that's just equals one factor of 5, like it's just 5, right? But say 25, right? 25 would be 5 times 5, right? And that's going to give us 2 factors of 5. Then 125 is going to give us 5 times 5, 5 times 5 times 5, which will be 3 factors of 5. So right now we're just trying to check how many times the current value has a factor of 5. So we can get rid of this right here. And then we're going to say, so we're going to say while value is greater than 0 and 2 and signs, value mod 5 is equal to 0, meaning it's a factor of 5, then we need to increment count for each factor of 5. So we can say $0 plus equals 1. Right, and then we need to divide by 5 to check to see if there are any additional factors of 5. So we just come down here and we say value divided by equal to 5. And that should be all she wrote, y'all. That will return the total number of trailing zeros. So let's run it, see how it runs, make sure it runs properly. Okay, so what does it say? Can I find value in scope? Okay, sorry y'all, this should be bar value, not just value. So that should be bar value. Let's run it again, see how it runs this time. Hopefully it goes through and it's accepted. So let's go ahead and submit it, make sure it stays accepted, y'all. Let's see. Oh, and look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Now, I'm going to just give y'all another solution, just because, you know, why not? It's a simple, the other solution is just as simple as this one, right? So I figure I might as well show it to y'all. So first thing we're going to do, we need a base case. If n is less than 5, then we already know that there are no trailing zeros. So we could just say if n is less than 5, then we can come right here, we can say return 0. Then we're going to come right here and we're going to say else. We're going to, should be no period right here. We're going to say else. We're going to say return n divided by 5. Then we're going to say plus trailing. So we're going to use some recursion. We'll say trailing zeros. Excuse me, this trailing zero should be in parentheses. Oh, excuse me, no, son. We're going to open up the parentheses right here. Sorry, y'all. Trailing zeros, then we're going to say n divided by 5 again. Boom. So let's clean this up again. Now, this is also using the same principles as earlier, where we're trying to just find the factors of 10, but instead of doing just 10 or 2 times 5, we're going to use 5. And it's the same principle. So let's run this again, see how it runs this time. This time we use some recursion, so let's see how that works. It's accepted, so let's go ahead and submit it. Make sure it stays accepted after we submit it, y'all. Let's see. Ooh, and look at that. 2 for 2. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. Those are the numbers I like to see. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.